Hello and welcome to this channel once again. In today's math tutorial, we will be showing you how to convert recurring decimals to fractions. But first, we need to talk about what recurring decimals are. You probably already know that 1/2 is 0.5. Also, 2/5 is 0.4. 3/4 is 0.75. 7/8 is 0.875. When you look at these fractions, when changed to decimal fractions, they actually ended somewhere, so we call them terminating decimals. There are fractions, however, that do not terminate when we convert them to decimal fractions. Let's take a look at some of them. Two over 3 is 0.6666 that continues indefinitely, so we can do 3 dot the ellipses to show continuity. We've got 5/6. This converts to 0.83333, adding the ellipses to show that the 3 continues indefinitely. How about 4/11? Which is 0.363636 that continues forever. 41/333 is another one, as this is 0.123 and it goes on just like that. Maybe one more, 2/7, and that is 0.285714. 285714, and so on, with a pattern repeating itself. Now, these are called recurring decimals. There is a way to write recurring decimals. For instance, the first one can be written as 0.6 with a dot on top of the 6 to show that the 6 continues. 0.8333 will be written as 0.83 with a dot on top of the 3 to show that the 3 continues on forever. The next one is written as 0.36 with dots on the 3 and on the 6 to show that the 2 continue, just like that. The next one is written as 0.123. Now, we could put dots on the 1, 2, and 3 to show that they continue like that forever. However, only the first and the last are necessary. So we could write it as 0.123 with dots on 1 and 3. And the last one is written as 0.285714. Again, we could put dots on each digit, but then it's only the first and the last recurring value that matter most. Now, let us see how to convert these recurring decimals to fractions. Make sure you just follow this video to the end, because there are many examples to learn from. And if you are yet to subscribe to this channel, please do so now. Click on the notification bell so that you do not miss out on any updates or new videos from this channel. To convert recurring decimals to fractions, it is super simple. Just follow through to the end. Now, the first one is 0.3 with the 3 recurring. First, we can let n be the recurring decimal. 0.3. This simply means that n is equal to 0.33333 that continues on like that. We call this equation 1. Then we multiply the equation 1 by 10. When we multiply by 10, the left hand side becomes 10n, while on the right hand side, the decimal shifts one place to the right, giving us 3.333, and the 3 will still continue on forever. Now notice how we align the numbers and the decimal point. It is very important. So all we do now is to subtract the first equation from the second one. And when we subtract, we're going to have 9n on the left side, and on the right hand side, it is going to be 3, as all the other 3's after the decimal points we cancel out. Then we divide both sides by 9, where n is 1/3 in its lowest term. Therefore, 0.3 with the 3 recurring is 1/3. Simple, isn't it? Now don't go yet. We still have more examples to show you how to get this done. The next one is 0.45 with the 4 and 5 recurring. So as usual, we let n be 0.45 recurring. And this simply means that n is 0.4545 that goes on just like that. That is called equation 1. And as usual, we multiply equation 1 by 10. When we do, we have 10n to be equal to, moving the decimal place once, 4.545454, and it goes on like that. This is the second equation. Now a look at this shows that the numbers after the decimal point do not align, and so subtracting it will not give us the desired result. So we multiply the first one by 100. Multiplying it by 100, we give 100n on the left side to be equal to, on the right side, the decimal point is moved 2 places to the right to give 45.4545. And that continues on to give us equation 3. Now, taking a look at equation 1 and equation 3, we could see that the numbers now align after the decimal point. So we could remove the second equation and subtract equation 1 from 3. This gives us 99n equals to 45, as all the digits after the decimal point cancel out. Then we divide both sides by 99 and reduce to the lowest term. Sure, n is going to give us 5/11. This thus means that 0.45 with the 45 recurring is 5/11. On to the next one. The next is 0.234 with the dot on 2 and 4, the last digit, to show that it is 234. So as usual, we let n be 0.234. This simply means that n is 0.234234 that continues just like that as equation 1. Then we multiply by 10. And that gives 10n to be equal to 2.34 just like that for equation 2. However, the digits after the decimal point do not align, so we multiply by 100 next. Multiplying by 100 gives 100n equals 23 as the decimal point shifts 2 places to the right, so 23.42343, and that continues, still not aligning with any of the previous equations. So we multiply by 1000, and this gives 1000n equals 234 as the decimal point moves 3 places to the right, and then we have 2, 3, 4, 2, 3, 4 that continues just like that for equation 4. It is then obvious that equation 4 and equation 1 align. Therefore, we can get rid of the second and the third one and then subtract equation 1 from 4. This gives us 999n to be equal to 234. Then we divide both sides by 999 and check if 234 over 999 can be reduced to the lowest term. Yes, it does reduce to 26 over 111. Hence, 0.234 with the 3 digits recurring is 26 over 111. We move on to the next. Here we let n be 0.16. Here it is only the 6 that keeps recurring and not the 1. And it simply means that n is 0.16666 with the 6 going on forever, equation 1. Then we multiply the equation 1 by 10, and that gives 10n equals 1.66 that continues on like that. The digits do not align here, and so we move on to multiplying it by 100. That gives 100n to be equal to, moving 2 places to the right, we've got 16.66666 that continues on like that, giving equation 3. Here, equation 2 and 3 align very well. And in that case, we're going to remove equation 1 and subtract 2 from 3. This gives 90n equals to 15. Then we divide both sides by 90, where n to its lowest term is finally 1 over 6. meaning that 0.16 with the 6 recurring is 1/6. Now, do not go yet. Let's take a look at this final one. It is a tricky one. It is 0.2679 with only the 7 and the 9 recurring. So if that is n, then we have that n is 0.267979 with the 7 9 going on forever. That is our equation 1. Then we multiply the equation 1 by 10. This gives 10n equals 2.679797979 that continues on like that as equation 2. Since the numbers are not aligning, we multiply by 100, and that giving us 100n equals to 26.79797979 that goes on like that for the third equation, and yet the digits do not align still. So we multiply equation 1 also by 1000. We continue this process until we could get just 2 of them aligning. This is going to be 1000n equals to 267.97979797 that goes on like that. That's equation 4. None of them align still. So we multiply equation 1 by 10,000. That's 10,000n equals to 2,679.79797979. Looking carefully at this shows equation 5 and equation 3 aligning. So equation 1, 2, and 4 are deleted, and then we subtract equation 3 from 5, and this is going to give us 9,900n equals to 2,653. We then divide by 9,900, and here there's no common factor between 2,653 and 9,900. And that simply means that 0.2679 with the 7 and 9 recurring is the same thing as 2,653 over 9,900. I believe this tutorial was helpful. Take the exercise 0.23 with the 23 recurring and leave your answer in the comments box. Make sure you subscribe to this channel. Click on the notification bell as you look forward to more of updates and videos from our channel. Thank you.